Table-GPT, Table-Tuned GPT for diverse table tasks. Language models such as GPT 3.5 and ChatGPT demonstrate remarkable abilities to follow diverse human instructions and perform a wide range of tasks. However, when probing language models using a range of basic table understanding tasks, we observe that today's language models are still suboptimal in many table-related tasks, likely because they are pre-trained predominantly on one-dimensional natural language texts, whereas relational tables are two-dimensional objects. In this work, we propose a new table tuning paradigm, where we continue to train/fine-tune language models like GPT 3.5 and ChatGPT, using diverse table tasks synthesized from real tables as training data, with the goal of enhancing language models' ability to understand tables and perform table tasks. We show that our resulting Table-GPT models demonstrate 1. Better table understanding capabilities by consistently outperforming the vanilla GPT 3.5 and ChatGPT on a wide range of table tasks, including hold-out unseen tasks, and 2. Strong generalizability in its ability to respond to diverse human instructions to perform new table tasks in a manner similar to GPT 3.5 and ChatGPT. A zero-shot language agent for computer control with structured reflection. Large language models, LLMs, have shown increasing capacity at planning and executing a high-level goal in a live computer environment, for example, MiniWoB++. To perform a task, recent works often require a model to learn from trace examples of the task via either supervised learning or few/many-shot prompting. Without these trace examples, it remains a challenge how an agent can autonomously learn and improve its control on a computer, which limits the ability of an agent to perform a new task. We approach this problem with a zero-shot agent that requires no given expert traces. Our agent plans for executable actions on a partially observed environment and iteratively progresses a task by identifying and learning from its mistakes via self-reflection and structured thought management. On the easy tasks of MiniWoB++, we show that our zero-shot agent often outperforms recent state-of-the-arts with more efficient reasoning. For tasks with more complexity, our reflective agent performs on par with prior best models, even though previous works had the advantages of accessing expert traces or additional screen information. LoftQ, LoRA-Fine-Tuning-Aware Quantization for large language models. Quantization is an indispensable technique for serving large language models, LLMs, and has recently found its way into LoRA fine-tuning. In this work, we focus on the scenario where quantization and LoRA fine-tuning are applied together on a pre-trained model. In such cases, it is common to observe a consistent gap in the performance on downstream tasks between full fine-tuning and quantization plus LoRA fine-tuning approach. In response, we propose LoftQ, LoRA Fine-Tuning-Aware Quantization, a novel quantization framework that simultaneously quantizes an LLM and finds a proper low-rank initialization for LoRA fine-tuning. Such an initialization alleviates the discrepancy between the quantized and full precision model and significantly improves the generalization in downstream tasks. We evaluate our method on natural language understanding, question answering, summarization, and natural language generation tasks. Experiments show that our method is highly effective and outperforms existing quantization methods, especially in the challenging 2-bit and 2/4-bit mixed precision regimes. We will release our code. The consensus game, language model generation via equilibrium search. When applied to question answering and other text generation tasks, language models, LMs, may be queried generatively by sampling answers from their output distribution or discriminatively by using them to score or rank a set of candidate outputs. These procedures sometimes yield very different predictions. How do we reconcile mutually incompatible scoring procedures to obtain coherent LM predictions? We introduce a new, training-free, game-theoretic procedure for language model decoding. Our approach casts language model decoding as a regularized imperfect information sequential signaling game, which we term the consensus game, in which a generator seeks to communicate an abstract correctness parameter using natural language sentences to a discriminator. We develop computational procedures for finding approximate equilibria of this game, resulting in a decoding algorithm we call equilibrium ranking. Applied to a large number of tasks, including reading comprehension, common sense reasoning, mathematical problem solving, and dialogue, equilibrium ranking consistently, and sometimes substantially, improves performance over existing LM decoding procedures. On multiple benchmarks, we observed that applying equilibrium ranking to Llama 7BE outperforms the much larger Llama 65B and Palm 540B models. These results highlight the promise of game-theoretic tools for addressing fundamental challenges of truthfulness and consistency in LMs. Towards joint language modeling for speech units and text. Speech and text are two major forms of human language. The research community has been focusing on mapping speech to text or vice versa for many years. However, in the field of language modeling, very little effort has been made to model them jointly. In light of this, we explore joint language modeling for speech units and text. Specifically, we compare different speech tokenizers to transform continuous speech signals into discrete units and use different methods to construct mixed speech-text data. We introduce automatic metrics to evaluate how well the joint language model mixes speech and text. We also fine-tune the language model on downstream spoken language understanding, SLU, tasks with different modalities, speech or text, and test its performance to assess the model's learning of shared representations. Our results show that by mixing speech units and text with our proposed mixing techniques, the joint language model improves over a speech-only baseline on SLU tasks and shows zero-shot cross-modal transferability. CodeChain, towards modular code generation through chain of self-revisions with representative submodules. Large language models, LLMs, have already become quite proficient at solving simpler programming tasks like those in human evil or MBPP benchmarks. However, solving more complex and competitive programming tasks is still quite challenging for these models, possibly due to their tendency to generate solutions as monolithic code blocks instead of decomposing them into logical subtasks and submodules. On the other hand, experienced programmers instinctively write modularized code with abstraction for solving complex tasks, often reusing previously developed modules. To address this gap, we propose CodeChain, a novel framework for inference that elicits modularized code generation through a chain of self-revisions, each being guided by some representative submodules generated in previous iterations. Concretely, CodeChain first instructs the LLM to generate modularized codes through chain-of-thought prompting. Then it applies a chain of self-revisions by iterating the two steps. 1. Extracting and clustering the generated submodules and selecting the cluster representatives as the more generic and reusable implementations. And 2. Augmenting the original chain-of-thought prompt with these selected module implementations and instructing the LLM to regenerate new modularized solutions. We find that by naturally encouraging the LLM to reuse the previously developed and verified submodules, CodeChain can significantly boost both modularity as well as correctness of the generated solutions, achieving relative pass at 1 improvements of 35% on apps and 76% on code contests. It is shown to be effective on both OpenAI LLMs as well as open-sourced LLMs like WizardCoder. We also conduct comprehensive ablation studies with different methods of prompting, number of clusters, model sizes, program qualities, etc., to provide useful insights that underpin CodeChain's success.